Funny, that doesn't seem anywhere near hard enough. Hear those angry noises cast iron makes when it's cooling. It just wants to crack again. Doesn't help that it's only about 40 degrees out here right now, and every once in a while a breeze comes up. I think I'll push my luck and not try preheating it with the torch. I don't think I'm doing a very good job preheating it anyways, without a proper heating tip on there. I also was having a hard time seeing the puddle, and I just realized that I had my helmet set to shade 11 and backed it down to shade 10. Idiot. I'll let that cool down a little bit, and then I'm gonna flip it around and hit that other groove I made. Should have started a new rod. I missed this whole area over here. This is so wide where I grounded it here that it's still pretty deep, so I'm going to make another pass. What changed? A little bit of a crater still right here. I don't know, I think once I grind this, I'm making kind of a mess there. I had a nice bead and now I'm kind of... Oh, so by the way, these are the US Forge part number 52332 nickel-free cast iron repair rods. They don't really leave slag like you would normally think of. It's kind of a weird powdery coating that just brushes right off. But anyways, they actually recommend using this for a root pass and then covering it up with a different rod, which I think I got some nickel rods to do that. All right, well, I wish I could tell you what these rods were, but I can't quite make out what they say on them. Looks like 1.5, no, I don't know, 15 something. But these are the rods that the guy at the welding place, when I told him what I was doing, that I was looking for something to do a covering pass, welding cast iron. I think these are 15% nickel, maybe. Is that what the 15 means? But I think they have nickel in them. So, and I think the reason why they don't want you using that cast iron repair rod, I think that's pretty hard stuff, because when I hit the welded area there with the carbide burr, sparks are flying. So, oh yeah, it would help if I put my helmet on. It's getting dark out here and it's getting hard for me to see what the hell I'm doing. I think I welded over some slag. Oh well. That sure runs differently than that last rod. Let's get a more traditional. I like my chipping hammer. Fill in this little area right here on the other side of the bolt hole. This angle, maybe I can get the back too. Oh, that's weird stuff. Well, it's a day later, and boy, what a difference a day can make. The temperature today is, right now it's only about 34 or 36 degrees. So it's a lot cooler today than it was yesterday. And so today I'm going to try and do some grinding on this to clean this up. So what happened yesterday was I was doing some passes with that nickel rod to do some cover passes, and I pushed my luck. What ended up happening was the video card filled up on the Hero, and so you guys missed that I did one weld, and then instead of waiting for that to cool down before I tried welding this side, what ended up happening was I welded one right after the other, and within like a minute after stopping welding, there was a very distinct ping noise, which is a dead giveaway that the casting had re-cracked itself. I haven't been able to determine yet where that crack is. I'm hoping it might just be over in this part over here, but we'll grind it some and see how bad it looks. All right, so it's pretty horrid. I think yesterday what I did was I didn't think that there was a thick layer of slag on the bead, and I think I inadvertently, when I rubbed it with the wire brush, thought I was looking at the bead, and I think I actually never got the slag off. I think this is all slag down in here that I welded over. So that's pretty horrid. And so the problem I have now is the only way I'm going to be able to really correct this is to grind all of this out of here and do it again. I actually can't find a crack, interestingly enough. So, I don't know. But you see, that's down in there, that's like a big pocket of garbage. So, I don't know. I don't know whether or not I should just leave it be. It's actually together. I don't know how strong it's going to be. I don't know how strong it really has to be. It's pretty much always in compression. I don't know. All right, I ground this back down and got rid of most of the inclusions, the slag inclusions that are in there. And the good news is I found the crack. This is where it cracked right there. You can actually see the crack. So it was just in this short little area that made that ping noise when it let go, as opposed to these larger areas which are more structural. So I'm happy about that. And I cleaned up the front. These inclusions go pretty deep, so I'd have to get a really small grinder to try and grind those out. And even then, I'm going to get a small grinder so I can try and get this little area out here. And then the plan is I'm going to try and run a new bead over the top of that. Alright, I changed to a grinding stone on my die grinder and was able to clean this up a lot better. So I was able to clean this out and make a nice groove in here. That's I think one bead in here should ground, when it gets ground back down, should bring me right where I want to be or close to it. This I had to be a little more aggressive. Might have to run 2 beads on this one. And then this I ground down and I can clearly see where it cracked. So hopefully. Backside doesn't look too bad, but I cleaned it up anyways, and I will run another bead there. Oh, I forgot to get that side there. Got to get all down in there. Alright, well, I'm satisfied that I've got it cleaned up to the point that I want it before I try and run another bead, but I brought it inside. I'm not going to bother welding it today because it's starting to already get a little bit dark outside. And, you know, while I'm under the helmet striking the arc, it might as well be dark out, but the problem is getting all the slag off and cleaning it up afterwards is what I'm going to have trouble seeing. Hey everybody, it's January 19th, another very unusual winter day here in New England. We didn't get any snow, we got some rain. It's 42 degrees right now. It was actually even warmer earlier today. I got home early enough that I decided to break out the stuff and hopefully finish the welding on this pan leg today. So I'm getting ready to preheat it. I decided, since I don't have a rosebud for my torch, I took off that welding tip and I put my cutting torch back on. And the reason why I want to use the cutting torch is because I figure if I don't pull the trigger on the torch, this outer ring right here should do well to heat that up a little bit quicker. Put more fire on it, so to speak. take this inside where it's a little warmer. Well, that was not a pleasant experience for me. I got the pan foot on top of the boiler. It's a little warmer up there, so hopefully that'll help it cool down a little bit slower, and hopefully it won't crack. I thought I heard a dull ping at some point when it was cooling, but I didn't see a crack. But then again, it's kind of hard to see with all that slag and that horrible, for lack of a better term, bead that I ran all over that thing. So I played around with the settings a couple times during the whole fiasco. Originally I had this control over here, this start adjustment. I had this up around 7 or 8, maybe even as far up as 9. And I didn't mess with that until today. With the cast iron, the US Forge or whatever the heck those were, cast iron repair rods, I didn't really seem to have much trouble running those. Those seemed to be making a nice bead, and I could control the puddle. What I found with these cover rods was that it almost seemed like the slag was covering the puddle so much that I couldn't see the puddle. So I adjusted the shade on my helmet down to 9, the lowest safe setting for arc welding. And then I think it's the lowest. Hope so. Anyways, then I changed the sensitivity a little bit on the helmet, and that helped me visualize the puddle a little bit better. But it almost seemed like also, for lack of a better term, it almost seemed like when I would start an arc, that the arc would want to like almost die out, smother. So I tried increasing the amperage. First I bumped it to 60, then I bumped it to 70. At 70, what I found was the rod was melting so fast and melting the cast iron so fast, I couldn't stay in one spot without almost gouging the metal. So I had to move kind of fast, and that wasn't good. So the last thing I did was I backed it all the way back down to 50, and that kind of solved the problem of it melting the base metal. And allowed me to slow down a little bit more, but I still had a hell of a time visualizing the puddle. So I'm not quite sure if that's just indicative of that rod or whether or not I'm just completely doing something wrong. I'm running DC straight polarity, which I know for the cast iron repair rods I was using, it said you can use either polarity, DC or AC. These cover rods I was just using, it occurs to me now, maybe I should have tried it on AC just to see what it would do. Well, I've decided that what I'm going to do is I'm going to, when this is fully cooled down, I'm going to grind it to clean it up, and whatever it looks like, as long as I don't see a big crack in there somewhere, whatever it looks like, no matter how ugly it is, that's how I'm going to put it into service. I'm not going to mess around anymore with this thing. This thing being the cast iron welding of the pan foot, not the welder. I still want to try and use the welder, but I think the next thing for the welder is probably going to be setting it up for TIG. I've got the full TIG setup that came with this, with a water-cooled TIG torch, and I'd like to try my hand at some TIG welding. I know I talked about maybe repairing a part on the SIP drill press, but I decided, since I had forgotten that I had already painted that part and put it back in service, and decided, I think, just to live with it the way it is. I'm not going to bother with that. So this is a cast iron piece right here. That is the part of the locking mechanism, and there's a rod that goes all the way over to the front that the elevation handle can be removed from the elevation shaft and put on that shaft. And when you rotate it, it actually, this thread threads into these two cast iron pieces right here. Well, this cast iron piece is supposed to be one piece. It pulls this cast iron piece in, which is wedge shaped, and actually acts to lock the table in position. Well, I think what I had figured out was that because it's screwed here and it's got a screw here, and because the brake is right down the middle of the threads, I think that when I tighten this, it still works. So I think that's why I decided the heck with it. Why bother welding it? My problem with welding it, of course, is it's cast iron, and I could grind this out and weld it. But what's going to happen is if I get anywhere near the hole and impinge on those threads, well, then I'm going to have to rethread that. And I think I'm learning now that the cast iron repair rods, they don't machine well. They're pretty hard. So I think I would have a heck of a time running a tap through there. And if I just did a little weld here and a little weld there, you know, I don't even know if that would make much of a difference than really the way it works now. Alternatively, if I really wanted to, I could just recreate this whole piece in steel, which would be much more flexible, because I think this is almost like a design flaw, the way this is made out of cast iron. I mean, that thing's being asked to basically to do some flexing, I think, in its life that it's just not happy with. So I'm going to leave that for now.